everyone, in this video we're going to talk about Demoivre's theorem. Now before I dig into the theorem and actually work on this particular problem, which is raising 2 times cosine of 330 degrees to the 5th power, before I do all of that, we need to lay the foundation of some background work. So let's look at the connection. Let's look at the connection between complex numbers and polar coordinates. All right, so this is our first task, and this is really important to understand because it's going to make everything else a lot clearer. So let's take a look at the point, the polar point, 2, 330 degrees. So if I were to plot that, I'm in polar coordinates. So I'm going to go out 2 units, and then I'm going to drive around that circle, starting from the positive x-axis. I'm going to drive around that circle counterclockwise until I hit the point, which is 330 degrees. All right, so I've driven all the way around, almost back to 360, but not quite. And I'm on that ray of 360 degrees. But my point is going to be right there. And I'm going to label that as 2, 330 degrees in polar coordinates. Now that certainly does also have a representation in terms of x and y, and we're going to discover what that would be. To make that connection very explicit, let's look at this little triangle. And we know that this angle in here, if we made our reference triangle here, the angle between the x-axis and our ray is going to be 30 degrees. So I'll just label that theta. Theta equals 30 degrees. So if I wanted to find the missing sides for x and y, first of all, we know that cosine of theta is adjacent over hypotenuse. So it's going to be x over 2. So in this case, I've got cosine of 30 degrees equals x over 2. Cosine of 30 degrees is square root 3 over 2, and I'm going to multiply by 2 on both sides. So I find that x equals the square root of 3. And then I could do the same for my y-coordinate. Sine of theta equals y over 2. Sine of 30 is 1/2. So y is going to be equal to 1. So I could equivalently label this point here, instead of 230 degrees, I could label this as square root 3 down 1. Notice here that I had to make the adjustment of being down 1 because I am in quadrant 4. Okay, so I could go and compute square root of 3 minus I all to the 5th power, and I could do out all of the binomial multiplications, and that would be a really long and hard way to approach this problem. But if I do Demoivre's theorem and I just look at this as z to the 5th power, then I can apply the formula and say that's going to be 2 to the 5th times cosine 5 times 330 degrees plus I sine 5 times 330 degrees. Okay, so if we multiply that out, we're going to have 32 for 2 to the 5th power, and then 5 times 330 degrees gives us 1,650. Now, to go from 1,650 to 210, notice that if I were to go out 32 units and then rotate around 1,650 degrees, I'd be going around that circle for a very long time, and eventually I'd end up here at around 210 degrees, which puts me in quadrant 3, and I've got a reference angle of 30 degrees. So I can keep proceeding with my trig calculation. And what this all boils down to is that I get negative 16 square root of 3 minus 16. Now, I'm interested in the cosine part of this, going back to my original question. And the cosine part of this is the real value part. It's not the imaginary component. Get the eye on down there. So I'm really just interested in the real part of this, which would be the negative 16 square root of 3.